Hi class, Dr. Searcy here with the video lecture for chapter 15. As you see, the title of the chapter is Correlation. So before we get into what correlation is, I just want to do a quick bit of review. Let's think about the measures that we've been using since about chapter 5. Right? In that chapter, I introduced the z-score to you. And we talked about how we're using it to find some area under a curve, and it's helping us to determine whether a significant amount it can be found in the tail of a curve or not. Then about chapter 9, we got into t-scores or t-tests, and we were using them very much the same way that we were using the z-score. Here, though, we used it to see if there was a difference between two different groups, right? So the independent measures, where we compare one group to another group, or the repeated measures, where it would be one group experiencing one condition and then experiencing another condition and seeing if their scores were the same. Then we got into talking about ANOVAs and using the F score in the same way that we've been using the T score, except with Fs. Now, instead of just looking at comparing two groups, here we're comparing more than two groups, right? Usually like three groups. Okay, so in this chapter, we are now going to move away from this type of analysis. Correlation is asking a slightly different question. And I want to go ahead and give you a sense of what that question is. I'm going to do it by defining what a correlation is. Okay, so simply put, a correlation measures whether two variables are related. Remember that a variable is anything that exists in the world that can be measured, right? And researchers are often interested in looking at different kinds of variables and how they influence our behavior or other things. Here, what we're looking at is, might one variable, right, if it changes, might the amount of change be related to how some other variable is acting on it? So I'm not sure if that's very clear. And because of that, I want to give you an example of a correlational study that I actually was involved in. Let me just note that for me, it's kind of a point of honor, because in this article that I presented as the extra credit assignment, I worked with this researcher here, Dr. Lester Wright, on a correlational analysis. So let me just kind of give you some background real quick. Lester Wright was a clinical psychologist at the university that I was studying at when I was working on my PhD. The type of clinical psychologist that he was he specialized in sexual deviance, right? So he would do things like measure whether someone had pedophilia tendencies, right? Whether they liked prepubescent children. He also studied factors like rape, why individuals engage in rape. But generally, when we talk about sexual deviance, we're saying that we're just looking at some sexual behavior that is different from the norm, right? Something out in the tails. Okay, so what happened was, it's about 2005, right? The year 2005. I had just gotten into graduate school, and I was having a conversation with this professor about events that were happening in 2005. At that time, the world was changing dramatically, but particularly with regard to the internet. In 2005, more and more people were starting to use the internet. At about that time, just about everyone, at least that I knew, now had an email address. And there was this big trend happening in 2005 where people that were cool had MySpace accounts, but now they were all migrating over to a new social social media company called Facebook. Okay. Now, this professor that studies sexual deviance and I were talking about this explosion of things that was happening in the internet. And we got into talking about how another big thing that was happening with the internet was the use of internet pornography. Dr. Wright mentioned how it looked like it was causing an extreme increase in that type of internet activity, right? Using pornography. And then we were talking about why that might be the case. Before the internet, if someone wanted to use pornography, they basically had to go to a store and buy it, right? And it could be embarrassing, all that kind of stuff. But now, in 2005, all of a sudden, all these new pornography websites are starting to show up. And people are no longer having to venture out of their house, publicly obtain it to enjoy it. Right now, they can consume pornography anonymously, alone, and comfortably in their own home. So, as Dr. Wright and I were talking about this, I saw that as a variable that I could measure. And I wanted to see whether using pornography might be related to a second variable, right? So we decided to collect some data on this question and to run a correlational analysis on it. So I just want to explain that to you real quick. And hopefully you'll get a sense of what a correlation is through this example explanation. So first off, let's just note that I recruited some participants to be in a study. In this correlational analysis, the thing that we were doing to the participants was just asking them a couple of questions. A first question, let me just note, so this is the column for the participant numbers. We got participant 1, 2, 3, and 4. In truth, there were about 30 participants, but to keep this explanation nice and simple, we'll just talk about 4 participants. Okay, so I asked them a first question. And that first question can be represented with this X variable, right? We can call it the X question or the X variable question. I asked them a question and then they gave me their answers. What was the question? The question was, how much does each participant engage in online sexual activity per week, right? How many hours did they use or consume internet pornography in a week? And I called it online sexual activity just because there's a lot of different ways that people can consume pornography, and so I wanted to have an umbrella term. So what were the answers that I got? Participant number 1 told me that he had engaged in online sexual activity for 9 hours over the past week. Participant 2 said 1 hour. Participant 3 said 7 hours over the past week. And participant number 4 said 0 hours over the past week. Okay, so that's my first variable. How much internet pornography is the individual consuming? I wanted to see whether this answer or this variable might be related to another answer or another variable. Particularly, it was this variable that I refer to as FWP, but in correlations we call it the Y variable. Okay, so what is this variable, FWP? What I was looking at was some measure of romantic partner relationship satisfaction. And that was basically what I was asking. Was the amount of pornography that someone consumed related to their relationship satisfaction if they had a romantic partner? Right, so I should note that every single one of these participants, they were someone who was involved in a romantic relationship. They had a boyfriend or a girlfriend. They were all college students, so I didn't have any married couples. Okay, but what is this measure of relationship satisfaction that I'm talking about, FWP? It is fights with partner, right? And what I asked them was, over the last week, how many times did you fight with your partner? Participant number 1 said they fought with a partner 6 times over the past week. Participant number 2 said they fought with a partner 2 times. Participant number 3 said 9 times. Participant number 4 said 3 times. Okay, so hopefully you are seeing a relationship between each participant's answers in one variable and their answer in the other variable. And that relationship is basically if someone engaged in a high degree of online sexual activity, that same person also tended to fight with their partner more as well. Conversely, if someone spent a small amount of time engaging in online sexual activity, they also tended to fight with their partner a small amount of time, right? And that's this relationship that I was looking to see if it existed. Here it looks like there is a relationship. Okay, so in statistics, we can't just eyeball this and say, oh yeah, it looks like there's a relationship, so there is a relationship. What we have to do instead is we have to conduct some type of statistical analysis, right? So here I started to write the name of the statistical analysis that we use in the correlational analysis, and I'll just kind of finish it up. This is a second take. My pen ran out of ink on the last take, so I'm now starting over. But we're saying that the statistical analysis that gets used is referred to as a Pearson R, right? That's a lowercase r correlation. And this is going to be a formula that we're going to punch these numbers into. You may notice that I've got some other columns here where I've taken our original X and Y values and manipulated them like you've seen in the past. For instance, in this column, I've took all the X's. I took each X and I multiplied it by its corresponding Y, right? So that's how I got that 54. It's 9 times 6 equals 54. 1 times 2 equals 2, and so on. And then in this column, I took each X and I squared it, right? So 9 times 9 is 81. 1 times 1 is 1. Over here, I did the same thing with each Y value. I squared those. 6 times 6 is 36. 2 times 2 is 4. Why did I do that? Well, the reason why I did it is because we're going to need these sums in our statistic, the Pearson R correlation. So let me give you a sense of what this statistical formula looks like then. Okay, so let's say that we're now moving on to correlational formulas. The Pearson R that we're talking about here is this formula. All right, so let me just draw an arrow. So it's that formula. What is going on in this formula? We're saying that we've got a division problem here where in the numerator of the division problem is this uppercase SP. And what does SP stand for? Oh, shucks, I wrote it down and I forgot where I put it. But it's basically this standard product of deviation. Maybe instead of trying to write all of that out, basically what this is, what the SP is it is another type of sum of squares value. And you'll see how that's going to be the case in a moment. But what's going on in this equation, right? So we're saying that the numerator is this funky type of sum of squares. The denominator is also a collection of sum of squares as well. What sum of squares? Well, here we're saying that we've got the sum of squares of the data in the X column times the sum of squares of the data in the Y column. Once we've multiplied those two values, then we have to find the square root of them, and that will be our denominator. Okay, so in this formula, you, by now, are masters at how to calculate sum of squares. You see this, and you know, oh my God, I got to come over here, and I got to add up everything in this column, then I probably got to square everything in the column, and then I got to pop it into that sum of squares formula, the computational. Dang, Dr. Searcy, you've made me a master of the sum of squares. You're welcome, student. Anyway, You may be asking yourself though, but how do I calculate this SP? What's the formula for that? Well, I'm glad you asked. Here is the SP formula. Right, so remember I referred to it as like I think it was the sum of the products of deviation scores. So basically what that's getting at is the difference between this score and that score, right? So how do we do that? Well, we've got a sum of squares equation that we do that with, right? So we got the sum of xy, that's this column here. You're seeing that it's going to be that 119, minus the sum of x times the sum of y over our lowercase n. Think you know what our lowercase n is in this sample? Okay, so at this point, the thing I want to show you now is how we go about solving this equation. First, let's just note what I did first. Right, so the thing that we have to do is we have to find the values for our R equation. To begin finding the values, I first went ahead and got the sum of squares of that x column and then the sum of squares of that y column. I tried to figure out what those were. And the values that I got were this. Sum of squares for the x column is 58.75. Sum of squares for the y column is 30. And just to remind you of how that, now you don't have to write this part down. I just kind of want to remind you of how we do the sum of squares equations, right? So to calculate each sum of square, I had to go get their sum of each column. Here it's 17, there's 20, right? The x and the y column. I also had to get their ends, and I needed to have their sum of x's squared as well, right? And so that's where I've got that 131 and then the 130. Once I got all of those values for each column, then I was able to pop them into our sum of squares equations, right? So that's that sum of x squared minus the sum of x in parentheses squared over 4, over the n. And so that's how I got the 58.75. Same thing over here with the sum of squares of y. This time it was 130 minus 400 over 4. And that's how we got this sum of squares of y. Okay, so I got those two values. Then remember the formula says that after that, you have to multiply them and then find the square root. So I multiplied them here. And then once I got some product, right, some answer from a multiplication problem, I took that product and I got the square root, and I ended up getting this 41.98. Okay, so that's the information. This is the information that we need to get our denominator. Denominator of our R equation. But how did I get the value for our numerator? How did I get the value for our SP? I've got that equation right here, right? So the equation is sum of xy, that's that 119, minus sum of x times sum of y, that's 17 times 20, over n, that's 4. So let's just cut to the chase, right? You know how to do the math on this. The answer that I ended up getting was 34. So now, at this point, I have the two values that I need in my equation. And so I can go ahead and calculate R. Thought I forgot to do it. Okay, so here then is our R equation, right? So our SP over the square root of SSX times SSY, it ends up being 34 divided by 41.98. And this is the value that we get, 0.80, right? That is our R. Now at this point, you might be asking yourself, what does that mean? What does 0.80 mean? What do we do with that? Okay, so I'm going to answer that question, but before I do, I need to also note how we would take this data and represent it using a graph. So I'm going to do that in this little spot here. And first, let's note that we're going to use a particular type of graph to represent the data. The graph we're going to use is called a scatter plot graph. Okay. And the way the graph looks is it has a y-axis and it has a x-axis, right? So x-axis and y-axis. And we have our x and our y axes already labeled up here, right? So our x-axis is that measure of OSA, the online sexual activity, and the y-axis is our measure of FWP, the fights with partners. Okay, so now what I need to do on my graph is have some representation of range, right, per axis. As I look at my x values, I see the range is from 0 to 9, and for the y-axis, it's 9 to 2. Now I want to make both axes mirror each other, so I'm going to go ahead and use the largest value as my end point on both axes. We'll say, because I have a highest value of 9, I'm going to make that my highest value here and also there. And so from here, then, we're counting down to, let's say, 0 right here. And so we'd have like 1 right there and 1 right there. So now we have the range of values for the online sexual activity and the range of values for the fights with partner measures. Now what we can do is we can plot each participant's pair of answers on this graph. I'll begin with participant number 1, right? So participant number 1's x value was 9, y value was 6. So I'm going to say, okay, for participant number 1, I see that they're on the 9 on the x-axis and at a 6 on the y-axis. So I'm going to say that that 6 is about right here, just over halfway. So this dot then is going to represent the two answers that participant number 1 gave me. They said 9 in terms of online sexual activity and 6 in terms of fights with partner. Let's now just go ahead and do that with the other 3 participants as well, right? So participant number 1, their x value was 1. So we know I'm going to draw the dot here, but how high am I going to go? Well, their y value is 2, and I'm saying the 2 is about right there on the y-axis. So that's where their dot will go, right? So that's a dot representing participant number 2's 2 answers. 1 in terms of online sexual activity, and 2 in terms of fights with partner. For participant number 3, OSA was a 7, so it's going to be somewhere right here, and fights with partner was a 9, so that's going to be a dot right about there, right? So it's participant number 3, 7 on OSA, 9 on fights with partner. Participant number 4 was a 0 on online sexual activity. So where's that dot going to go? It's going to go right here. But how high up? Well, there are 3 on the y-axis. It's going to go up 1, 2, 3. And that's where their dot's going to be. Okay, now we have just plotted the 4 data points that our participants gave us. And let's think about what we see going on here, right, with these 2 participants versus these 2 participants. Basically, one thing that we can say is if a participant was high on one axis, they're also going to have a high score on the other axis, right? So a 9 here, or what was it? A 7 here and a 9 there. Same kind of thing here. A 9 here and a 6 there. Conversely, if a participant was low on one of the axes, they also were low on the other axis as well, right? A 1 versus a 2, a 0 versus a 3. Okay, so now with that, you've just learned two important bits of information about how to interpret a correlation. You've learned about how to calculate a Pearson R, and you've learned how to graph correlation data. From here, I now want to spend the rest of the lecture explaining how we interpret these two things. So we'll move now to characteristics of R, right? So ways that we can describe the Pearson correlation. The first thing that we need to talk about in terms of characteristics is strength. What we mean by strength here, though, is we're talking about the strength of the relation, right? So we're asking, are two variables related to each other? Here is a measure. If they are related to each other, how much are they related to each other? So the way that we determine that is we look at the numerical value of R, because it indicates the strength of the relationship. By numerical value, we're basically asking ourselves, how big is the number that we've calculated, right? And in this case, our number was 0.80. So how big is that in terms of the Pearson correlation? Well, the way that we interpret it is we basically look at it this way. We say to ourselves, the R that we calculate is going to be some number between 1 and 0, right? So it's going to more than likely be some decimal value that's smaller than 1, but bigger than 0. For instance, our correlation was 0.8, right? Smaller than 1, but bigger than 0. Okay, so what does it mean, whether it's a 1, a 0, or somewhere in between? Well, if a R that you calculate is a 1, that indicates a perfect relationship, right? So for everyone in the sample, they were affected. One variable was perfectly related to the other variable. That's what a score of 1 means. Score of 0 is exactly the opposite. It's saying that if you calculate your R and you get 0 or close to 0, there's no relationship there. The two variables are not related to each other. They do not change in relation to each other. Okay, so with that, I want to just show you scatter plot data with R values to make sure that you get a sense of what we're saying here. Here we have a group of 3 different R scores. Here's another group of 3 different R scores. And then there's an interesting R score right there. Let's look at these R scores that are positive values first. Right here is a bunch of R scores that are all negative. Let's just look at the positive ones for a moment. Right, so I said that if you have an R of 1, that means there's a perfect correlation, right? And that would be represented this way on your scatter plot. Basically, as you move up 1 unit on one axis, you're moving up exactly 1 unit on the other axis. And so that's why your data looks so perfectly aligned, right? It's a perfect relationship. Ours wasn't that perfect. Ours was this 0.8, right? So ours is more like this data, right? And that's pretty much what we got, right? We could say that we had the same thing. If we in their data, they're drawing a line through the data. If we drew a line through our data, we would see that our data has exactly the same pattern as this example data. And if we probably added more participants, right, we'd also get more dots along the same way. So that's saying that there's a good correlation, right? There's a good relationship between one variable and the other variable, but it's not perfect. So what happens as the value reduces? Here, now we've got an R of 0.3. What you're seeing is the relationship isn't as strong. It doesn't look like there's a one-to-one match. For instance, think in terms of the people that scored high on this axis. That does not seem related to where they score on the other axis, right? So for the people that are here on this axis, you've got one person that's there on that axis, another one that's there, another one's there. You got someone that's over there, right? So being here does not predict where you are over here the way it does over here, right? So here we're saying if I have a low score here, then I'm also going to have a low score there. If I have a high score here, then I'm also going to have a high score there. Now, as we go to a R of 0, right, where we said there was no relationship at all, that's what this would look. That's what it would look like then. Think about again having a high score here, right? So you got several high scores, but they're all over the map on the other axis. So this is where we're saying whatever I do on this axis is not at all related to what I do on this axis when I have a R of 0. Over here, so we're saying that these are negative values, but you see the same type of relationship. Again, we're just talking about how large the number is, and we'll say the absolute value, right? So we still have a 1 being a perfect correlation, an 8 being a really good correlation, and a 0.3 being a not so great correlation. Okay, so now let's talk, now that we've talked about the strength, right? And basically what we're getting with the strength is we're saying, as a researcher conducting a study, I want my R to be high. I want to be closer to 1, the way it was here. Okay, so that's one characteristic of how we look at and interpret a Pearson correlation. Another characteristic that we have to consider is direction. By direction, that now is where we're referring to this this positive value versus a negative value, right? So that's what you're seeing. Positive values on this side of the data, and then negatives, I'll show you. And then negative values here. Okay, so what does it mean when the R is a positive value versus what does it mean when the data is of a negative value? Well, if your R is positive, it means that your X and Y vary in the same direction. What do I mean by that? I mean that if you have an X score that's high, then you're also going to have a Y score that is high, right? And that's what we got going on here. I had a X score that was high, and I also have a Y score that is high. Okay, and I guess you could say that it doesn't matter what the strength of the correlation is. If you have a positive relationship, the positive relationship is going to exist even in a low correlation. Okay, right. So we're still tending to see this pattern where if I have a high score, then I have somewhat of a low score, even though it's not as pronounced because it's a small number. Okay, so then what does it mean if I have a negative R score? Well, what that means is your X and Y vary in opposite directions, right? So let's take this data point, for instance. On this axis, it's a high score. But on the opposite axis, it's a low score. And so that's what we mean by the data vary in opposite directions. Let's take this score as another example. Over here, the score is high on this axis, but it is low on that axis, right? They vary in opposite directions. And when that happens, you generally get this downward trend with the data. Okay, so that's how we interpret a Pearson R. Let me ask you real quick. As far as direction, what do we have here? Do we have a positive value or a negative value? We have a positive value, right? There's no negative sign here. So what does that mean? That means that we have a positive relationship. And that's what we're seeing here, right? So look at this pattern. You're seeing that same pattern with the data there. That's that positive relationship. Oh, it even says it here, positive relationship. Okay, so now I have one last point to make with this, and that is this idea that in correlational analyses, we cannot discuss causation. What do I mean by causation? I mean that we cannot say that one variable's answers or behavior influence the other variable's answers or behavior. For instance, when I conducted this study, one thing that I wanted to say was that online sexual activity, well, let's say high online sexual activity, was causing the participants to then have a high number of fights with their partners, right? That was causing that. I cannot say something like that. I cannot talk about cause. Why can I not talk about cause? Well, there's a couple of reasons. First reason, though, is we do not know what the actual causal variable is, right? We don't know where the relationship began. Here, I just suggested that it was the high pornography use that caused the high degree of fighting. But it could be the exact opposite. It could be the case that maybe the couple fights a lot, right? And they don't get along. So because they fight so much, one of the partners engages in a lot of online sexual activity to make himself feel better, herself feel better. Okay, so we don't know which variable is causing the other variable to change. Right, so that's a first reason why we cannot talk about causation. But then there's a second reason why we can't talk about causation. And that second reason is that there could be a potential third variable that you, the researcher, are not aware of. Right? Maybe it's the case that here we have two variables. There's actually a third variable that's influencing both of these. What could that third variable be? Let's say it could be something like infidelity. Infidelity. I'm glad I don't know how to spell it. Means I haven't had to deal with it very much. Okay, infidelity, right? What's infidelity? That's being unfaithful to your romantic partner. Maybe this is the variable that's influencing both that and that, right? Maybe you have a significant other, but that significant other just likes to flirt or, gets the attention from others and doesn't turn that attention down. And maybe because that's happening, the couple are fighting a lot and one of the partners is looking for some kind of alternative satisfaction. Okay, so that's what we're talking about with this potential third variable being another reason why we cannot explain causation. Okay, thank you very much for your time. That is all I have for this lecture. I look forward to seeing you in the next lecture.